and third starter. So first thing we'll do is differentiate. So tan 3x. Well, tan, using your formula booklet, differentiates to sec tan. The angles stay the same. So sec 3x tan 3x. We have to times by the derivative of the bracket. So stick a 3 in the front. D by dx will differentiate ln squared plus 5. Remember, you get 1 over x squared plus 5 times by the derivative times by 2x. So 2x by x squared plus 5 and differentiate cos 5. Well, remember, that means cos x to the power 5. So the rule for that is 5 times cos x power 4 times by the derivative of the bracket, so minus sine x. So you get minus 5 cos 4x sine x. Remember, cos x power 4, we write like that. Second one, we have two functions. F of x is x squared plus 5, and g of x is 16x squared plus 5. You want the transformation. Well, only the x's look like they've changed. So that means it's definitely just the x. And it looks like it's being times by something. So it looks like it's a stretch. Now, it's not being times by 16. So we need to write this as something squared plus 5. So something squared gives us 16x, so just 4x. So g of x equals f of 4x. That's a stretch. X direction, or parallel to the x-axis, whatever phrase you like. Scale factor, do the opposite, so a quarter. 3, so binomial starts 1 minus 6x plus 27x squared. We need to find a and n. Well, let's use the form as how to start. It will be n times x plus n minus 1 over 2 times x squared. So that will give us 1 plus n x plus n minus 1 over 2 a squared x squared. So we've got two equations. We have na equals minus 6 and n minus 1 over 2 a squared equals 27. Now look, 27 is the bit in front of the x squared, minus 6 the bit in front of the x. So just solve them simultaneously. So we would get from this first one, a would equal minus 6 over n. Sub it into here, so we get n minus 1 over 2 times minus 6 over n squared is 27. So we get, run out of space, we can see here, n minus 1 times, well, the top's going to be 36, and the bottom, when you get to the squared. Well, now the 2 and the 36 can cancel out from the 18 on the top. 1n cancel out one of those n's. I can times it by n now. I can expand this bracket, so 18n minus 18 is 27n. Take the 18n to that side, take a 9n, and divide by 2, divide by 9, get n equals minus 2. And as soon as I got n, I can sub it back into a. So a is minus 6 over minus 2, so a is 3. Yeah, so rearrange one of them to get a equals, or I could have rearranged to get n equals, it would just be a lot nastier, so an n into there. Yeah, and then just expand that up, so 36 over n squared, so 36 on the top, n squared on the bottom, simplify the fraction, then just rearrange and solve. Fourth one, geometric sequence, so we need the formula un, it's ar minus 1, and we know the second term is 80, so ar is 80. The fifth term, so ar4, is 5.12. So I'm going to do this one, divided by this one. When I divide them, look, I get just r cubed is 0.064. Cube root it is 0.4. That's R. Sub R back in, so we'll sub back into the first one. So A equals divide by 0.4, 200. So I've got A and R now. Now when the sum to infinity, the sum to infinity is A over 1 minus R. So that's 200 over 1 minus 0.4, which is 6. So as a fraction, that's 1,000 over 3. And last one, all is thrown vertically upwards from a height of 2 meters. And the speed going up is 5. How long until the ball hits the ground? Well, I need to put the acceleration on, so gravity going down. So if I try and do a suvat, I need to remember to choose which way is positive. So ball's going up initially, so I'm going to make up my positive. So S, from here to when it hits the ground, S is minus 2, and this goes down by 2. U is 5. B, I don't know the speed on the ground. It's minus G, it's going down, and T is what we're trying to find. So look at the formula, this is UT, is half T squared. Sub it in, minus 2 is 5T, it's half times minus 9.8, so minus 4.9 T squared. Take it over to one side, 4.9 T squared, 5T is equal to 0. Stick me a calculator. 4.9 minus 5 minus 2. So you get two answers. One's positive, one's negative. You can't have negative time, so choose the positive one. Two significant figures, 1.3 seconds.